Hi my students, today we are going to complete the last lesson of gases law. At the end you will know the second law of gas and third law of gas. In the beginning I will make small revision about the first law of gases. We said before that behavior of gases based on the following properties, which are pressure, volume, amount, and temperature. We started with the first law of gases, which is Boyle's law. We know before that Boyle's law linking between pressure and volume, and we know how is the pressure applied to a gas related to its volume. Boyle's law states that at constant temperature the volume is inversely proportional to applied pressure. The formula of Boyle's law written as P1 V1 equal P2 times V2. This for Boyle's law. In conclusion, the harder we push, the smaller the gas volume gets. So, Boyle's law is P1 V1 equal P2 V2. Now we are going to solve this question that related to Boyle's law. But I hope to pause the video and start to solve this question alone. After that, revise the answer with me. If the pressure of helium gas in a balloon has a volume of 4 liter at 210 kilopascal, what will the pressure be at 2.5 liter? We can predict the answer. We said before that the pressure and volume inversely proportional. In this question, the volume is decreased. It means the pressure increased. So the second pressure should be more than 210. To solve this question, we will use Boyle's law, which states that P1 V1 equal P2 V2. We have first volume and first pressure, so 4 times 210 equal P2, which is unknown, second pressure unknown, times 2.5. 4 times 210 equal 840, which equal P2 times 2.5. To get P2, we will divide it by 2.5. So 840 divided by 2.5 will equal 336 kilopascal. So second pressure is more than first pressure because the second volume less than first volume. This for Boyle's law. After that, we will start with the second law of gas, which is called Charles' law. Charles' law relates the volume of gas to its temperature. How is the volume of a gas related to its temperature? Or what happens if heat is applied to gas? As we see, the volume of gas increases by increasing temperature. So, at constant pressure, the volume is directly proportional to the temperature of a gas. This for Charles' law. So, Charles' law states that at constant pressure, the volume of a gas is directly proportional to its temperature. But why did the volume change? Why did the volume increase by increasing temperature? Or what happens to the average speed of the gas molecules? As we know, by increasing temperature, number of collisions between particles and between particles and wall of container increase because the speed of molecules increase. This means that the volume of gas will increase also. So by increasing temperature, the speed of molecules increase, thus lead to increase in the volume of gas. To write the formula of Charles' law, we will use its definition. We said that volume is directly proportional to the applied temperature at constant pressure. So the formula will be V1 divided by T1 equal V2 divided by T2. T1 and T2 is absolute temperature in Kelvin. So we will use temperature in Kelvin, not in Celsius. We can convert from Celsius into Kelvin by adding 273. We will see it later in the questions. We will solve these questions which related to Charles' law. A gas sample at 40 degrees Celsius occupies a volume of 2.32 liters. If the temperature is increased to 75 degrees Celsius, what will be the final volume? We have first temperature and first volume, but only we have second temperature, and we want to get the final volume or second volume. In this case, what will we do? Firstly, I give you the temperature in Celsius. We can't use temperature in Celsius, we should convert it into Kelvin. So, firstly, we will change from Celsius into Kelvin. First temperature, which equal 40 degrees Celsius, will equal 40 plus 273, it will equal 313 Kelvin. Also, second temperature, 75 degrees Celsius plus 273 equal 348 Kelvin. This is the first step. After that, we will use Charles' law, which says that V1 divided by T1 equal V2 divided by T2. V1 first volume, which equal 2.32, divided by first temperature, which equal 313, equal second volume, which is unknown, divided by second temperature, which is 348. Cross multiplication, so V2 equal 2.32 times 348 divided by 313. So final volume will equal 2.58 liter. Also, the volume increase as temperature increase. This proves Charles' law, which states that direct proportion between volume and temperature at constant pressure. This for Charles' law. Third law of gas, which called the pressure law. This law relates the pressure to temperature of a gas at constant volume. By increasing the temperature of the gas, its pressure will increase. By increasing the temperature, the particles' kinetic energy will increase and its speed also increase. This causes increasing in number of collision between particles and wall of container. And we know before that pressure of gas resulted from collision between particles and wall of container. So, by increasing temperature, number of collisions between particles and wall container will increase, so pressure will increase at constant volume. So, pressure law or third law of gas states that at constant volume, the pressure of the mass of gas is proportional to its temperature. Also, temperature in this formula is in Kelvin. This is known as pressure law. When we draw the relation between temperature and pressure, we will get a straight line which started from 0. This graph below shows the pressure of a fixed mass of gas at constant volume is directly proportional to the absolute temperature in Kelvin. Absolute temperature means temperature in Kelvin. So P1 divided by T1 equal P2 divided by T2. This for pressure law. P1 first pressure, T1 first temperature, P2 second pressure, T2 second temperature. T1 and T2 are the absolute temperatures. This for third law of gas. So we learned three laws for gas, which are Boyle's law, Charles' law, and pressure law. Also we know that pressure of gas produced by or resulted from the collisions between particles of gas and wall of container. Now we will solve this question that related to pressure law. The pressure of a gas in a tank is 3.2 atmosphere at 22 degrees Celsius. If the temperature rises to 60 degrees Celsius, what will be the pressure in the tank? Pressure equal 3.2 atmosphere. ATM mean atmosphere. It is the unit of pressure. We know before that pressure has more than one unit, which are Pascal, atmosphere, and Newton per meter square. Atmosphere is the unit of pressure. In this question also he gave us the temperature in Celsius, so we should convert from Celsius into Kelvin before using pressure law. So first step, we convert from Celsius into Kelvin. First temperature 22 plus 273 will equal 295. Also second temperature 60 plus 273 equal 333. After that we will use pressure law, which is P1 divided by T1 equal P2 divided by T2. P1 equal 3.2, T1 equal 295 equal P2, which is unknown, second pressure unknown, divided by T2, which is 333. To get B2, cross multiplication, so B2 equal 3.2 times 333 divided by 295. So final pressure equal 3.6 atmosphere. This is the end of our lesson. Try to solve your homework that uploaded on Moodle. Thank you, my student.